The last topic we discussed was CUCME, and we also did a lab for CME, in which we registered two phones, one through SIP and other through SCCP. So let's go ahead with that now. We discussed about CUCME, its features, router based. It has a virtual CME interface as well, through which you can do some GUI configuration, but that is limited access. So most of the configuration is done through command line only. So you have to know what commands are used for what purpose in CME. And as it's a small scale solution, it supports maximum up to 450 device, and it supports registration and 113 active calls concurrently and provides call processing. The protocol used in this are SIP and SCCP, and for the communication remains the same RTP and RTCP for controlling of the call. Endpoint configuration, we discussed that there are some protocol and some uh, configuration process that the phones, IP phones goes through, like power. It needs CDP to get the VLAN information. It needs DHCP for IP configuration. MAC address is used for the registration process, so it can be manual or auto. And TFTP is the CME itself, which provides the configuration files. Endpoint capabilities are different, like screen characteristics, codec support, button navigation cluster, speakerphone and headset support, number of lines, video support, other features. These are some phones which are supported by CME. This is the registration process, which remains the same whether IP phones are getting registered through CME or CUCM. We discussed about the IP phone firmware, how the endpoint firmware is loaded. It is loaded from the CME itself, which is the TFTP server. So a service on TFTP server, which is the CME, answers with the appropriate .load file, which is the firmware. And we did this lab in which we configured and registered one CIPC through SCCP, another through SIP, and there was a communication between these two. We have configured different commands for SCCP and SIP. Next, we will see dial plan components. So in dial plan components, it includes endpoint addressing, call routing and path selection, call coverage, digit manipulation, and calling privilege. These are all the components of dial plan. So endpoint addressing, like we did in the previous lab to give the DN numbers, providing all the required information like VLAN, IPs, DNs, lines, any additional features needs to be configured on the endpoint. All that comes under endpoint addressing. Call routing and path selection, how we have to route the calls, like for the gateways, which gateways should be used for which particular calls, and so on. We can do under call routing and path selection. Call coverage to make sure all the calls are answered. So we discussed about different methods for call coverage, like shared lines, for individuals, and group pickup, call park. For group, we have another call coverage method like call hunting, call queuing. Digit manipulation, when you are making calls outside to the PSTN and when you're receiving calls from PSTN, digit manipulation is used because internally we usually do not use the standard numbers. We use numbers like 3-digit, 4-digit, 5-digit numbers only, which are not the standard numbers. Then to make them standard number, we need to do some digit manipulation, like add a prefix. And when the call is coming from outside, then removing the prefix, stripping off the digits, and then making the call to the original number, and so on. That all comes under digit manipulation. Calling privileges to allow or deny access to certain calls or numbers, that comes under calling privileges. So here in endpoint addressing, we can see we have a CUCME. There are some phone numbers assigned to endpoints like 1001, 1002, 1003, 1099, and so on. That is it. This is how endpoint addressing is done that we already saw in the previous lab also. This is a part of endpoint addressing. Then next is phones and DNs. Now, different features for phones and DNs are there that we will see now, like name, SCCP. So in an STCP phone, the command or the term that we use for phones is ePhone, and directory number is ePhone DN. So like we configured in the lab also for ePhone 1, ePhone DN1, like this, we were using the terms. So that is for STCP. In SIP, we configure voice register pool and voice register DN. For phone, voice register pool, and directory number is voice register DN. Now, what it is, the phones are represented in CUCME configuration and software configuration that represents the line connecting a voice channel to a phone, that is directory number. Identifier used for phones is a tag or a sequence number, whereas identifier used for directory numbers is a DN tag or a sequence number. The number of entities is the number of registered endpoints, that can be phones, and number of simultaneous calls. Each directory number represents a virtual voice port in the router, that is a directory number. So basically, phone is a hardware, directory number is a software, and phones in this we includes the endpoints, and any configuration related to the endpoint is configured on the phone, and on the directory number we configure software configuration. Then for associations, phone can have one or more directory number associated with it. Directory number can have one or more telephone numbers associated with it. That is a part of like shared line. We can configure shared line on the same phone or on different phones. Same way, a phone can have more than one directory number, and directory number or the same directory number can be on more than one phone. Binding can be done. Phone MAC address ties the software configuration to the hardware. So MAC address is used for the binding for phones, whereas directory numbers are assigned to line buttons on the phone. Now, what is the impact on dial plan? There's no impact on the dial plan for phones. Whereas for directory number, for each directory number, one virtual voice port and one or more dial pairs are created. Next, single and dual line DNs. So for single and dual line DNs, we will see the characteristics of both. So starting with voice channels per button. In single line directory number, there is only one voice channel per button. In dual line directory number, as the name says, it has two voice channels per button. Telephone numbers are supported, one for STCP and 1 to 10 for SIP. In dual line directory numbers, one or two, that is primary and secondary, is supported for telephone numbers. In single line directory numbers, the usage scenario is that the lines dedicated to intercom, paging, MWI, uh, message waiting indicator, or music on hold can be used for usage scenario. Whereas for dual line directory number, the line supporting call waiting, call transfer, or conferencing can be done. Endpoint support for single line directory numbers is SIP and STCP. For dual line directory numbers, STCP only. So here we can see an example that a call comes to 1001, it gets answered. A concurrent call to 1001 will get a busy tone in case of single line directory number. Whereas in dual line directory number, a call comes to 1002 and gets answered, and a concurrent call can also come to 1002 as it's a dual line. The first line can be on hold, and if we have an option to merge or make conference, we can do that. But in single line, only one call at a time will work. Here we can see multiple number DN. A call to 1001 or 1002 comes in, it gets answered. If you have multiple DNs, that is associated with different lines. Now, call routing in CUCM Express. So for call routing, we have to know how the connection is done through from the CUCME to the outside network, can be PSTN or IP network. So two types of dial pairs are configured. Okay, for call routing, dial pairs are configured. The two types of dial pairs are these, VoIP and POTS. So VoIP is used for IP network, like for example, MPLS or IP connection, or POTS is used for T1 even. Although T1 even is not used nowadays, we use ITSP. Like we have ISP, similarly we have ITSP, Internet Telephone Service Provider. This is what is used nowadays. Okay, so this is one of the commands that you can use on the CUCME to verify your dial pairs. So you can do show dial pair voice summary. It will show you the different dial pairs it has. So you can see the type. You can see VoIP, POT, dial pair, their status. You can or operational status. You can see the prefix if any available for these for figures. Destination patterns, these are for the different numbers. We have created destination patterns. So this is for one destination, this is for another destination, this is for international number, for example, for PSTN with the prefix 9 like this. Okay, so this is how you can verify the dial page.